Now, this time we will look at the masses, but we'll have a table with friction. You can see the friction 1 and friction 2. And these are not the same value because friction depends upon the weight, and little mass m has a larger or smaller weight than big mass m, so the friction will be different. Let's look at little mass m and isolate it and find the net force. Net force is ma. P is accelerating it as a force acting to the right. Opposing that is T and F1. So I can write down P minus T minus F1, that's the net force there, equals ma. So now let's look at the other one. Now this time I have a T, now that should be actually drawn larger, acting to the right, and F2 opposing it, and it should be smaller, and my net force would be T minus F2 equals big Ma. And so that gives me the equation for that on that mass, F equals Ma. So we have the two equations. Now let's look at the big picture. Let's see what happens if we can apply F net equals Ma to both masses and accelerate the system. So we say to ourselves, okay, what is F net? And we know we need to find F net equals m, but by m we mean the total mass that's being accelerated times a. So we look here, and m plus m will equal the total mass. So what is the net force then? Well, here's P, and that's the larger force acting to the right. Now, what is opposing that P on that system? Well, F1 is, and so we subtract F1 and we subtract F2. But we don't worry about the tensions because they cancel each other out. They're only a connector joining the masses, but they're not affecting the acceleration of the system. So there's our F net, and it's m plus m, big M plus little m, times a. And there's F net equals ma. But what is the friction? Well, we know that friction is equal to mu, which will be the same for both masses, we're assuming they're the same, times the normal force. And in this case, the normal force is simply the weight. W is mg. So let's see what it is for each friction. So for F1, the friction will be mu times little m times g. For F2, it will be mu times large M times g.